What is up, my peoples? This is lesson 1 for module 2.3. Let's get into it. We are about to talk about the focus and directrix of a parabola. So previously we learned that a quadratic function, the graph of that is a parabola, and it can open up or it can open down. And then there's this line that goes right through the middle that like cuts the parabola in half, and we call that the axis of symmetry. Also, what else do we know? A parabola can be defined as a set of all points in a plane that are equidistant from a fixed point called the focus. So that's what your focus is. It's a fixed point. And a fixed line called the directrix. So the directrix is a line, the focus is a point, and every point on the parabola is equidistant from the focus and the directrix. Okay, let's see if we can figure out what that looks like, what that means. The focus is always going to be on the inside of the parabola, the interior of the parabola, and it's always going to be on the axis of symmetry. The directrix is always going to be perpendicular to the axis of symmetry, and it'll be in the exterior of the parabola. The vertex, this is important. The vertex of the parabola is halfway between the focus and the directrix. And that makes sense according to the definition, right? Because the vertex is a point on the parabola, so it has to be equidistant from the focus and the directrix. And remember that when you're talking about the distance between a point and a line, it has to be the perpendicular distance. Because if I'm going to say like, well, how far is this point from the line? I can say, well, look, it's really far if I go over here, but it's not so far if I just go right here. So it's always the minimum distance is the perpendicular distance, and so that's the one we call the distance from a point to a line. Alrighty then. So if there's some point here, we know that the distance from this point to the focus is equal to the distance from this point to the directrix. And we know that it's that this is perpendicular right here. So any other point, right? This point is equidistant from the focus and the directrix. And we know that both of these bad boys are perpendicular, because that's how we measure the distance from a point to a line. Let's take a look at an example. Use the distance formula to write an equation of the parabola with focus f, 0, 2, and directrix y equals -2. Alright, let's take a look at this. Well, the focus is 0, 2. So over 0 up 2, bada bing, hey, there's that. The directrix is y equals -2. So that is the line where all the y values of all the points are -2. So if you think about that, we're going to have 0, -2, we're going to have 1, -2, we're going to have 3, -2. All the y values have to be -2. Those points are like here, over 0, down 2, bing, over 1, down 2, bing, over 3, down 2, bing. So that's a horizontal line that goes through the y value, -2. And there it is. All right, now what? Distance formula. How's the distance formula going to work? So we got a parabola in there somewhere, right? It's going to be halfway between because the vertex is halfway between. So the focus is 2 up, the directrix is 2 down, so our vertex is at the origin. And our parabola is going to open up because our focus is above. Now let's pick a point somewhere on this line. I mean, somewhere on the parabola. It's not a line, it's a parabola. This is a line. Anywho, okay, we got a point now on the line, and what do I know about that point? Well, I know that the distance from the focus to this point is the same as the distance from this point to the directrix. And let's see, I know the coordinates of this point. The coordinates of this point, we're just going to call those x and y because this represents any point on the parabola. This point here, what do I know about this point? Well, I know the x value has to be the same as x. It has to be the same as the x value of this point. And the y value, since it's on this line, has to be -2. So this point we can call, and we'll just call it D because it's a point on the directrix, x comma -2. So this x is the same x value that our point has that we picked on our parabola. We don't know what this y value is yet. Alright, so let's figure out what can we do. What's the distance formula? Distance formula, if you have 2 points, call them x1, y1, and x2, y2, then the distance between those 2 points is the square root of x1, or it doesn't matter which way you subtract them as long as you're consistent, x2 minus x1, that means like the horizontal distance between those 2 points, squared, plus y2 minus y1, or the vertical distance between those 2 points. And this is the distance formula, and it's derived from the Pythagorean theorem. So how am I going to apply this formula, because they tell us to this problem? Well, I got 2 distances here. So I'll start with this one. So I got this point, 0, 2. So I've got 0, 2, and I've got xy. And I'm going to flip those because my brain likes it better this way. Because what I do is when I'm doing the distance formula, I put my points on top of each other so that I remember to subtract in the same order. So this distance is, let's see, subtract the x values and then square it. So x minus 0 is just x, square that, plus y minus 2, square that. So that's my distance between the focus and the point. Let's find out what we can figure out about the distance between the directrix and this point. So the 2 points I have here are x, y, that's my point on my parabola, and x, -2. The distance between these 2 points is the square root of x minus x, which is 0. So 0 squared, well, that's just going to be 0. That 0 looks like a D. And I don't even need it there because 0 plus whatever is just whatever. So I don't have to write that. Y minus 2, no, y minus -2. What happens when you do y minus -2? Minus a negative. Taking away something bad is good. This turns into y plus 2. And that is squared. Because remember we had 0 squared plus this squared. Okay, now this is the part where the definition of the focus and directrix definition of the parabola comes in handy, because we know that this distance is the same as this distance, so I can set this junk equal to this junk. And let's do that. Alright, so the square root of x squared plus y minus 2 squared equals the square root of y plus 2 squared. Square root of this equals square root of that. My heart tells me to exponentiate both sides of the equation, or raise both sides to the second power, or another way to say it would be square both sides. You square a square root, you get the inside, which is also known as the radicand. So we get x squared plus y minus 2 quantity squared equals the quantity y plus 2 squared. So the parentheses are important here, and I say the quantity y plus 2 squared because that is also important, because what does this little 2 mean up here, this second power? It means the base times itself twice. So I'm going to go off to the side and say, well, y plus 2 squared, what that means is y plus 2 times y plus 2. And now it's a little easier to see that I got to do all this FOIL stuff. Or the other way to call it is using the distributive property twice. Y times y is y squared. Y times 2 is plus 2y. 2 times y is plus 2y. And 2 times 2 is plus 4. These guys are like terms. 2y plus 2y is 4y. So on this side I get y squared plus 4y plus 4. If you don't do this step over here, sometimes you'll look at this and go, oh, y squared plus 4, and then you miss this term, which makes your answer all wonky. All right, over here we get, I'm going to scoot my x squared over a little bit because I know I'm going to have to multiply this out and get a big trinomial here. So if I do y minus 2 squared, that's y minus 2 times y minus 2. Y times y is y squared. Negative 2y times y is negative 2y. So I did this and this. Now I can do this and this. I get another minus 2y. Negative 2 times negative 2 is positive 4. So my like terms here add up to a negative 4y. So I get y squared minus 4y plus 4. So y squared minus 4y plus 4. Have you forgotten what we're even doing? Because I have. Now I gotta, what am I doing? I am using the distance formula for like 20 minutes to find an equation of this parabola. Okay, I just needed to remind myself what the heck is going on here. All right, I got an equation here that I need to try to solve, simplify. I want to get an equation of a parabola, and those are quadratic functions that look like y equals something going on with an x squared, right? Ax squared, however you look, there's other stuff too, right? So that tells me that I would like to try to get y by itself in this equation here. That would be neat, because then I would have a quadratic equation because I have an x squared, and that's the equation of a parabola, and then I'd feel like a winner. So let's see what we do here. Let's see. Here's something interesting. I got a y squared and a y squared here. I got a 4 and a 4 here. What happens if I subtract y squared from both sides? Y squared minus y squared is 0, so those go away. Y squared minus y squared is 0, so those go away. That's cool. What happens if I subtract 4 from both sides? And as a side note, why am I writing it under the 4? Just because I know that that's the like term that it's going to be combined with, right? It wouldn't make sense for me to write minus 4 under 4y because those aren't like terms. I can't combine them. I'm just writing it once on the left side of the equal sign, once on the right side of the equal sign, but I'm going to put it under the like term that it would cancel out with or would combine with. 4 minus 4 is 0, so that goes away. 4 minus 4 is 0, so that goes away. And I got my x's over here and a y over it, so I'm going to get the y's off of here. This is minus 4y, the opposite of that is plus 4y. If I'm adding 4y to the left side of the equal sign, I got to add the exact same 4y to the right side of the equal sign. Negative 4y plus 4y is 0, so that goes away. Positive 4y plus 4y is 8y. So we get 8y over here, we get x squared over here. That's kind of the equation, but I'd like to make it pretty by getting y equals something, right? So I'm going to divide both sides by 8, and I get y equals, and if I want to have it in like the a times x squared, I got to remember this, x squared is 1x squared, so 1 over 8 is 1/8 x squared. Ding! Hey look, yellow and blue makes green. That's cool. Well hey, that's the end of the video. That's the end of this lesson. You are amazing. You are my hero. You watched this whole video, and that warms my heart. That makes me feel special. Please, at this point, if you have any questions, shoot me a message, and go ahead and start the practice 1 for module 2.3. Bye-bye. Stay awesome.